Alright, today's lesson is lesson number 63. We're going to be evaluating logs using a calculator. So we're going to focus on common logs and natural logs. So you'll be getting decimal answers today, but again, you're using your calculator, so it shouldn't be too difficult. And let's go ahead and get started. So here are the steps. The first thing you're going to want to do is make sure that you're working with the correct type of log. So a common log is going to look like this. It has either log base 10, or because it's so common, sometimes they just make the 10 like invisible, kind of like how we have an invisible coefficient of 1 in front of x. Sometimes they'll just put log. Okay, so that's going to be the common log. Right? Or if we have a natural log, which is log base e, or it can be rewritten as ln. They kind of take the L and then the N and flip them. So that it stands for natural log. And e is just a number for us, okay? It's kind of like pi. Remember pi from circles, right? Pi is 3.14. E is about 2.7. Okay? So it's kind of a special number. It comes up a lot in math, but for us, we're just going to think of it as another base that we can use our calculator for. Okay, so after you've determined that you have the correct type of log, then you can use a calculator to evaluate the expression, and you'll write your answer to the nearest thousandth. Okay, so that means if I have 2.1235, this 5 rounds the 3, right? So my answer would be 2.124. Okay, that's the thousandth place. Alright. So here's our first two examples. Remember, this is just like saying log base 10 of 5. Okay, it has that invisible 10 here. So from yesterday's lesson, we would set this equal to x and rewrite it as an exponential. So we would have 10 to the x equals 5. Okay, and if we think about our powers of 10, we know 10 to the 0 is just 1. 10 to the first power is 10, and 10 squared is 100. So we know that 5 is somewhere right in between here, so it should be right in between 0 and 1. Okay, and here's a screenshot of what your calculator on your iPad looks like. So if we were to plug this in on the calculator, here's what we do. We push this button first, the 5, and this will change to a 5. And then we push the log base 10 button, which is right here. Okay, so once you push 5, then log base 10, you would get your answer. Alright, so doing that on the calculator gives me a final answer of 0.6989, and again rounding to the nearest thousandth. That would give me 0.699. Okay, so you could write that up here. So log of 5 equals 0.699. Alright, moving on to number 2. Again, you're going to hit those same buttons on the calculator. But I could think of this, before we do that, I should think of this as log base 10 of 17.1. That's equal to some number. And I can rewrite this as an exponential equation, which means 10 to the x equals 17.1. Okay, again, looking back over here at my powers of 10, I know that 10 to the 0 is 1, 10 to the first is 10, and 10 squared is 100. 17 is going to be in between 10 and 100, so I know my answer should be between 1 and 2, probably closer to 1, since 17 is much closer to 10 than it is to 100. Okay, and if I push 17.1, then the log base 10 button on my calculator, I get an answer of 1.2329. Rounding to the nearest thousandth gives me 1.233. So log of 17.1 equals 1.233. Okay, a couple more examples now. Same thing here. If I try this on my calculator, push 3 first, then log base 10, I'm going to get an answer I know that 10 to the, this is the same as log base 10 of 3. So that means 10 to some number gives me 3. So I know 10 to the 0 is 1. 10 to the first power is 10. So my answer is going to be somewhere in between 0 and 1. And if I put this on my calculator, I get 0.477. Okay, same thing here. This is going to work out in the same way. So this, when I rearrange it, I'll get 10 to the x equals 70. I'm thinking, okay, that's going to be somewhere in between 10 to the first power and 10 squared. Probably closer to 10 squared. So my answer is probably going to be sort of close to 2. Okay, so if I plug this in my calculator, I get log 70 equals 1.845. Okay, so not too bad, right? Just being able to use the calculator correctly. But if this was on a test, you might need to have to approximate. So that's where this idea comes into play, where I'm thinking, what kind of number should I get? And you see here 1.845, like we said, is between 1 and 2, but closer to 2. Okay? Okay, so now 5 and 6, let's look at number 5 first. This is like log base 10 of negative 58 equals x. So 10 to what power equals negative 58. And this kind of goes back to yesterday's lesson. Remember that an exponential cannot be negative, okay? So if we look at the graph, for example, of an exponential, remember that it kind of goes like this, right? It gets close to this asymptote of y equals 0, but it doesn't hit it and it doesn't go below, okay? There's nothing down here. So it's undefined there. Okay, so you would say this is undefined. And then the same thing happens here because it's just any negative, right? So this would also give me undefined. All right, and now moving on, here are some examples with ln. Remember that ln is our natural log. This is the same as log base e. Okay, so trying to figure out what this is equal to, I can set it equal to x and then convert it to an exponential equation. Okay, so I'm thinking, okay, e to what power equals 0? E, remember, is about 2.7. Sorry, e is about 2.7, so this is almost like saying 3. It's close to 3, right? So I'm thinking, okay, 3 to the 0 equals 1, 3 to the first power equals 3, 3 squared equals 9, and so on. But of course we know that anything equal to 1, any exponent equal to 1, the x has to be 0, right? Anything to the 0 power gives me 1, so I can tell right away that x has to be equal to 0 here. But you could check on your calculator. The natural log button says ln, and it's right next to the one that was log base 10. Okay, so you'll push 1 first, push the number first, and then push this ln button. Okay, and that will give you your answer. So doing that would also give you 0. Okay, for this one, you're thinking, all right, this is the same as log base e of 6 equals x, so e to what power equals 6. Looking over here, I know 6 is between 3 and 9, so my answer should be between 1 and 2. Right there in the middle somewhere. So if I do this on my calculator, I get 1.792. Okay, so a little closer to 2 here, but still in somewhere between 1 and 2, right, like we guessed. All right, last couple examples. ln of 50, again, doing this on, if I try to write this out, this is like log base e, which I can rewrite like this. And my powers of 3. Again, e is about 2.7, So I'm going to approximate using 3. Okay, so these are my first few powers of 3. I note that 50 is between these two, so my answer should be between 3 and 4. So I'll go and do it on my calculator. Okay, so that gives us, on the calculator we would get 3.912. Okay, so for this problem then, ln of 50 is going to be 3.912. And as we guessed, that's between 3 and 4. So that solution would make sense then. Okay, now for this one, ln of 3.3, we would be looking at e to the x equal to 3.3. So you'd see this is going to happen somewhere between 1 and 2, right? Because 3 to the first power gives me 3, and 3 squared gives me 9. Again, e is not equal to 3, but it's about 3. So I can use this as an approximation. And then 3.3 is in here, but it's pretty close to this, so my answer is probably going to be pretty close to 1. And if you put this on your calculator, you'll see the answer you get is 1.194. Alright, and that's it for today's lesson. Thank you.